Let's talk about revising for the written paper at both GCSE and A-level for design and technology. We all know that revising for the subject is generally quite hard because you might not know where to start, and in school you probably focus too much sort of on the coursework and not enough on the theory side, which is also worth 50% of the marks. So both the NEA and the written paper are equally weighted when it comes to your final grade. There's a lot of content for DT, and especially so at A level, and it's annoying because only some of the topics will actually come up in the paper. But anyway, there's high yield topics that for sure will come up and be worth most of the marks in the paper. And then you've got your smaller niche topics that are less likely to come up. And if they do, they would be small mark questions. So I'd start off by making a list of all the big topics and look at your exam board and your specification for this. The big topics might be something like materials and properties, manufacturing processes, sustainability and life cycle analysis, design movements, health and safety, legislation, etc. Then find some notes for these topics. You probably will have things and worksheets and stuff from class and stuff in your exercise book. Apart from that, look at textbooks. So this is the textbook I had at GCSE, and this is the textbook I had at A-level. And bear in mind, I did an Excel for both exam boards at both. For now, focus on the high yield topics, especially if you're aiming for a high grade, but not necessarily the highest grade. And then once you're confident with those big topics, go through the remaining smaller topics. In terms of revision strategies, once you've got your resources, please don't just read through the textbook and think you're learning. There's more engaging and active revision methods out there. So for example, blurting and flashcards are the two that I would primarily recommend. Before I explain both of those and how they work, which I'm sure you will know that anyway, I want to emphasize that you do not need to memorize large chunks of information. This isn't a subject like history that is memorization heavy. It's more like science, where the questions are application based, not regurgitating facts. Use lots of pictures of products to link back to things like material properties. So for example, this bottle here is made of PET. It doesn't matter if you don't know what PET is, or you don't know what properties that PET has, you can work it out by looking at the bottle. So if ask yourself, what properties does this bottle itself have? Well, obviously it's lightweight, it's transparent, it's waterproof. These then are your three properties, or three of some of the properties of PET. If this bottle was made with something like oak, would it have those same three properties? No, it would be quite opposite. It would be quite heavy, even if it was the same sort of thickness of oak. Oak is a denser material than the PET plastic, so it would be heavier. It would be opaque, and it wouldn't be waterproof. So pull up photos of products that you can sort of visualize in your head when you think about these materials, and it's going to help you massively versus just memorizing words. Blurting then is useful if you want to get an overarching sort of sense of your knowledge on a particular topic or the overall subject. So grab a blank piece of paper, write the topic name in the middle like materials, and then try to write everything you can remember about that topic. Then check with your notes and fill in the gaps with maybe a different color. Do that a few times and I promise you'll remember way more, and you'll end up with actual summary sheets that you can then revise from that are nice and condensed. For learning content from scratch, I would recommend flashcards. Again, avoid big chunks of text on your flashcards, but for materials, you might have the material name on one side and a picture of some example of products on the other side with the few properties as bullet points. DT is not a memorization subject, and the sooner you understand that, the better. If we're thinking about real-world applications, is far more important than just learning facts. DT theory also makes way more sense when you connect your ideas, which goes for learning basically anything. For example, with plastic, with polymers, link them to the manufacturing processes, like injection molding or vacuum forming. This way, you can revise multiple topics at once by merging them together. You need to be doing lots of past papers to practice, and obviously this goes for any subjects, but particularly with the mark schemes, we can use those to revise and essentially put the bullet points from the mark schemes onto flashcards for a particular question and memorize those and learn those answers directly from the mark scheme. At A level, the questions are longer, but the idea is generally the same. They're testing your reasoning and your ability to apply your knowledge to a scenario-based question. When you mark your answers, don't just see sort of what you went wrong with. Look at why the mark scheme's answer is better and why it's maybe worded better or worded in a more concise way. Okay, let's talk about the coursework and how we can sort of use that to help us with the theory. If you're sketching a product, think about what materials or processes you would actually use to manufacture it and why. That way, you're making choices about materials throughout your coursework, and in the exam, you will have a better sense of materials. If you 3D print something, for example, find out what material the filament is made from. You've got to be proactive. So DT is one of the few subjects where you get to be quite active in your revision. You get to be quite hands-on with the content. You learn about the materials and you see the materials physically in your workshop. So interact with the objects, the materials, and the processes that you've got available to you in your workshop, and you will naturally end up picking up information that you can then use in the theory paper. About 15% of the GCSE DT paper will be made of maths questions or maths-based questions, depending on the exam board, and this increases to about 20% at A level. You need to bring a calculator with you into the exam and practice these sorts of questions to do with material cost and volume, and shape and geometry, etc. You also get a drawing question where you need to draw a product in a particular way, whether it's isometric or 1 or 2 point perspective, or in orthographic, which is basically sort of 2D. So teach yourself how to do this. This is what some of those drawing techniques look like. A couple last things then. DT is a very visual subject, so look at YouTube to see manufacturing processes in action and look at products and pictures that use certain materials, as I mentioned before, with lots of images. If you've got any questions, leave them below and I'll get back to you. I hope I've made your DT sort of revision a bit clearer for you, and have a look at the other videos for coursework and theory help on this channel. Bye!